Welcome to CML INFOTECH. My name is Muhammad Ali. Today we are talking about switching concept and practical session from CCNA. As we discussed before, the switching, which means sending data within the network or sending data system to system or device to device which are in the same network. So let's say switching basics. So there are switches from different vendors. Irrespective of vendor, basically we have layer 2 and layer 3 switches. Even if you think about Cisco, Juniper, Extreme, Aruba, Avaya, Dell, D-Link, and so on. If any branded vendor switch, that switch either it belongs to layer 2 switch, which are switching, or it belongs to layer 3, which is routing. So generally a switch will contain like CPU, RAM, then operating system. Operating system, which means iOS, Inter-Network Operating System. You can see here a switch has ports and the LED which indicates the status of the switch. This is one of the example, like you can see Cisco switch and the number 2960. This is the front side of the switch, and in the switch by itself you can see starting from 1 to until here, which is 48 ports. This ports we call as downlink, which will be connected to the edge device. It may be laptop, camera, or let's say access points, or IP phone, access control system, anything. And these are the last corner, which you can see for ports. The top two considered as SFP ports, or on the bottom two we can consider it as a copper port. So these generally will connect it to the other switch, which are also known as uplink ports. And this is the backside of the switch. Generally it contains the uh, power connector, then the fan. Then you can see also an RJ45 model console port for configuring the switches. So the console port will be using to configure the switches, routers, any network devices. The switch by itself will have an operating system called iOS, Inter-Networking Operating System. To configure those that we're going to use console ports. സ്വിച്ചിൻ്റെ iOS-നെ സ്വിച്ചിനെ മാനേജ് ചെയ്യാൻ വേണ്ടിയിട്ട് യൂസ് ചെയ്യുന്നതാണ് കൺസോൾ പോർട്ട്. We'll let you know more about RPS. This is the another model of the switch where it has additional ports. Like as an example, you can see stack-wise ports. This is the different model of the switch. The stack-wise ports we will be considered, let's say if you have a two switch, we will be connect two of them as logically one. Then the RPS is redundant power system, which means, let's say you have switch 1 and switch 2. If you have a two switch with the same model, same iOS, same vendor, then you can logically make them as single switch. So this will be logically will become a single switch. How? We will be using dedicated stacking cable. We're going to use a dedicated stacking cable, one or two. Generally we're going to use two, and we'll bind them by giving certain configuration. We'll learn about this, how we can make stacking between switches. So when somebody looking into the switch, by it has a physically separate ports on both the switches, but it logically act as a single switch. So this stacking cable will be used for data traveling. Same way, we can also use power stacking, one or two. Power stacking, which means the switch by itself will have power which is connected to our power socket to get the power. Some switch will have, this is power 1. Some switch may have 2 power. This is 3 pin. P2. Or some switch will have a single power. So let's say here also I connected power, and this is we call as a AC power. So as an example, in this switch, switch 2, if this power goes down, what's going to happen? The switch doesn't have redundant power, or the switch by itself will shut down. So if a switch lose the power for some reasons, maybe power goes down or the cable goes down or power outlet had some issues, etc. The power goes down. So this switch will produce the power or to share the power to the switch 2 via this specific cable, which called power stacking. That's we call as RPS, redundant power supply. So in this, either we can use stacking for data stacking or power stacking. These are the optional cases, but you can do the stacking either data or power if you have same vendor, same model, same image, then you can do that generally. So we'll go back to here. So here you can see that redundant power supply. Then the remaining are same, like RJ45 for configuring the switch. So here you can see two additional ports, which for stack-wise ports for stacking. Stacking is nothing but to make multiple switch as logically one. Depends upon the model and the vendor. In some model that we can make maximum 4 as one group, one stacking, or some model can do up to 8 switch as one stack. Example, Cisco 2960 we generally do with the 4 switches maximum, and 3750 switch will do maximum up to 8. And within the switch that we have two, unmanageable and manageable. Unmanageable, which doesn't have OS, doesn't have console port, you can simply connect and we can access it, and there is no configuration required on. Manageable switch will have a console port that then you can configure those switches. So when you think about configuring a switches, it contains many different level of configurations. We'll learn each one individually in detail. Then within the manageable switch, generally we consider two models, layer 2 switch and layer 3 switch. So in Cisco, generally, if any switch which contain lower than 3000 model, then we call it as a layer 2, and above layer 3, above 3000 series, which are layer 3, will consider as a layer 3 switch. So here you can see 3000, then 3560. So 3000 is called a series, 3560 is called a model from those specific series. The layer 2 switch, which means it can perform only switching, which means if you have a switch with the layer 2 model, you can make only a single network. If you are trying to make a dual or more network in one layer 2 switch, then of course you need the layer 3 device, either router or layer 3 switch to make them interconnection, which is known as routing. We learn individually in detail about all these topics. So here you can see that switch which contain, this is, you can see 110 slash 100 slash 1000 speed, let's 1 gig ports. Then you can see that SFP module, which is for fiber connection. Generally, we're going to use fiber to get more speed than your downlink to communicate with the different switches. Either you can use a copper port or you can use a fiber ports. So the best practice to connect between switches is going to use fiber link, either single mode or multi-mode. We'll let you know what is single mode and what is multi-mode. And here you can also see the NM network module. So the one you can see network module slot for uplink ports as an optional. You can see those in some model which you can see 2 and some model you can see 4. Either it's going to be copper or it's going to be fiber, and some will have with the 1 gig and some will have with the 10 gig speed, so that we need to order it what kind of uplink post that we need. The best practice and recommended solution that if you have a switch with a downlink 1 gig, then the best practice to have uplink with the 10 gig. If you have a downlink 10 gig, better to have a uplink 40 gig, 100 gig or above, like this. Okay, we'll look into the
So can you explain that once more?
Yeah, sure. So if you have a switch, the switch will have generally two set of ports, one downlink, one uplink. The downlink is used to connect your edge devices. As an example, uh, let's say within the switch, we will tell, uh, as an example, we can say, within the switch, as we said, we have layer 2 switch and layer 3 switch. The layer 2 switch only for switching, the layer 3 switch switching plus routing. The layer 2 switch below 3000, example 2960. The layer 3 switches above 3000, example 3560. And there are various models, 4000, 5000, 6000, 9000. There are many different series of switches. Even from 9000 series, starting from 9000 series, we will also have a layer 2 switch, which are the new models. Now, when you design your network, we will follow a set of rules. As an example, we're going to say 2-tier hierarchy, 3-tier hierarchy, or 4-tier hierarchy, which means, let's say you have internet connected to your office. In the office, the first thing that you should have firewall for filtering your traffic. Then it comes to maybe you have redundant firewall or single firewall. Then it goes to a layer 3 switch. Then we're going to do stack. The best practice we're going to talk about, always required dual switch for redundancy. This switch, which is facing to your firewall towards your external, we called as core switch. Core switch. Let's say the latest series of the one of the core switches 95X 9500 series of layer 3 switch. Then this switch will have connection to another two set of switches, and these are stacked or interconnected, and we'll have a connection one to this switch and one to this switch. Or we also in some time will refer to do that we can also have a cross connection for the full redundancy, full bandwidth. This is, we call it as server farm switch. When we say server farm switch, always the server farm switch will be responsible to connect the servers. Example, I have a one physical server here. This physical server, let's say, will have a two connection, will goes to switch 1 and switch 2. Then we'll make it a bundle. Then we call it as NIC teaming. NIC teaming. Then we have another set of switches, let's say 1 and 2, and we will do stacking. This is called access switch, AS, in a simple way. A, S, C, W, access switch. Then we'll get the connection 1 to switch 1, 1 to switch 2. This is switch 1, core switch 1, this is core switch 2. So what we have here, this is core switch, this is server farm switch, then this is access switch. Access switch, we will consider generally layer 2 switch. Based on the company budget, they can use any different number or series of switches. Some people will use very low end model, or some people will use very high end model. Depends upon their budget. But here what we're going to consider, this access switch will have camera, we have phone, we have PC, or we have access control system, ACS, or we have PDU. Hope you heard about PDU. PDU is nothing but the device which can produce the power. Or we have UPS, all that we can connect it to the network switch for monitoring purpose. Like the PDU, we can monitor to address the power utilization. So these all we call as edge device. So according to access switch, the device which connected as edge, this is we call as downlink. The switch and this downlink is generally UTP cable or copper cable. And from the access switch, which you connected to the core switch, this is we call as uplink. So when you have your downlink, which is connected to your access switch, have 1 gig speed, recommended solution, your uplink must be 10 gig. Your uplink must be 10 gig. Or let's say the core switch, always with the core switch will have speed, we'll consider this access switch, we're going to use 10 gig. And the server farm switch, we're going to use 40 gig, because the servers will have more traffic than your edge devices like a PC. So depends upon the edge device that you're going to use, and to based on the traffic that produce, we will have a kind of physical connectivity. So this may be 10 gig or maybe 40 gig. So every switch will have uplink and downlink. The uplink generally considering between switch to switch or switch to servers, and the downlink will be considered in between access switch to the edge devices. Hope you understood. So let's say in this you can see that we have many different set of switches. Example, we have 3560. So above 3000, this will considered as layer 3. So that the name called multi-layer switches, MLS, multi-layer switch, which means the switch can act in multiple layers. When I say multiple layers, it can be layer 2 or it can be layer 3. By default, all the switches will start from layer 2, even if it has the capability to act as a layer 3 or multi-layer switch, it starts from layer 2. Then you can see here another switch called 2960, which is layer 2. And let me open the switch. Here you can see the switch, layer 3 switch, which you can see 3560 PoE, which means power over Ethernet. When you connect any device which the device doesn't have additional power ports, നമ്മൾ എഡ്ജ് ഡിവൈസിൽ കണക്ട് ചെയ്യുന്ന, അതായത് സ്വിച്ചിൽ കണക്ട് ചെയ്യുന്ന ഡിവൈസിന് എഡീഷണലി പവർ ഇല്ല എന്ന് വിചാരിക്കാം. എക്സാമ്പിൾ ക്യാമറ, ആക്സസ് പോയിന്റ്. അപ്പം അത് കണക്ട് ചെയ്തിരിക്കുന്ന സ്വിച്ച് തന്നെ അതിന് പവർ പ്രൊഡ്യൂസ് ചെയ്യും. So this port starting from 1 to 24 will consider as downlink, and you can see the other two ports. This will considered as uplink. So the downlink have lower speed and the uplink will have higher speed. Then we can take the, so let's say if you go for CLI, it will give you the first screen says that would you like to enter the initial configuration. If you put yes, you have to put each command one by one. If you put no, you have a choice to give which commands the first which you need. Like if I put no, then you can give any commands. Yes കൊടുക്കുകയാണെങ്കിൽ അത് തന്നെ ഓരോ ചോദ്യം ചോദിക്കും. സ്വിച്ചിന്റെ പേരെന്ത്, സ്വിച്ചിന് ഏത് IP വേണം, അത് ചോദിക്കുന്നതിനനുസരിച്ച് നമ്മൾ കൊടുക്കണം. നോ കൊടുക്കുകയാണെങ്കിൽ നമുക്ക് ഇഷ്ടമുള്ള കമാൻഡ് ഇഷ്ടമുള്ള സമയത്ത് നമുക്ക് കൺഫിഗർ ചെയ്യാം. Enable. Okay, we'll talk about the commands. We can take another switch. Let's say here we have a 2960, which is layer 2 switch. So this layer 2 switch, you can again see that it has 24 ports and it can see 2960 series. Then you can see uplink ports. Then if I click here also, you can see that you have a 26 ports total, one switch, the model of the switch, then the OS operating system which it has, 12.2 version, all the information that you can get while you boot the switch. You can see that serial number of the switch, serial number, then the MAC address of the switch, all these informations. Also, we'll go into access the original the physical switch. So let's say I'm going to connect the physical switch. When you think about physical switch, you need a power cable to power on the switch. Then you need a serial to USB converter, as we said in the let's say the switch by itself, you can see on a backend there is a RJ45 console. You need to use a console cable to connect. In the laptop, you don't have RJ45 connection directly. Therefore, we're going to use converter, serial to USB converter. Then there is a software called Putty, Putty, that we're going to use. So this is the Putty software. Then when you connect your USB cable from converting switch with console cable, it will automatically detect your COM number. Either you can use a putty or you can use a Teraterm open software. Teraterm, Teraterm or putty. Then if you go to device manager, if you put start and device manager, then ports, you come to know what port number that's it used. അവിടുന്ന് നമ്മളെ പോർട്ട് നമ്പർ ഏതാന്ന് നോക്കിയിട്ട് ലെറ്റ്സ് സേ പുട്ടി സോഫ്റ്റ്വെയർ എടുത്തു. ഇതിൻ്റെ ജനറലി നിങ്ങൾ പുട്ടി സോഫ്റ്റ്വെയർ എടുക്കുമ്പോൾ ക്ലോസ് ചെയ്തിട്ട് ഞാൻ പുട്ടി സോഫ്റ്റ്വെയർ എടുക്കുന്നു. അപ്പോൾ അതിങ്ങനെയാണ് വരിക. ഇതിനകത്ത് നമ്മൾ യൂസ് ചെയ്യുന്നത് സീരിയൽ ടു USB കൺവേർട്ടർ വെച്ച് സീരിയൽ പോർട്ട്. ഇത് COM1 ഡിഫോൾട്ട്, നമ്മൾ യൂസ് ചെയ്യുന്നത് COM3 ഓപ്പൺ. So let me see. So hope you can understand today's topic. So if you have any concern, let me know. We can discuss inshallah. So today we just discussed about the basics about switch and how to access the switch. We will continue with the upcoming session, part 2, to know more about the switch configuration. Thank you for being with us. Thank you from CML INFOTECH. Have a good time.